Then it's working.
Yeah, it's on.
Yes. Hello and welcome, everyone. This part of this session, we will welcome you to a dialogue, but for the sake of recording, we're making a recording of the first part. And in that, before coming into reflections with Q&A and exchange of experiences that we welcome very much, we are extremely happy to have you here and the opportunity to present some of the results of Bioze, a project focusing on potentials for biogas development. And who are we? Well, we were glad to be funded in the first batch of a small-scale project of the Interreg North Sea area. Myself are coming from West Sweden Energy Agency, or as we say in Swedish, Energikontor West. And I'm happy to have Johannes as a professor at University of Twente in Netherlands. The joining organization has also been Bioze, also from Netherlands, and 3N from Germany, EM Normandy, and we're all been good and well coordinated, and other many contributions from AIL in France as such. And the agenda is pretty straightforward. We will just go through a little bit of the deliverables and the project, but then we'll focus on one of the deliverables. We have had several, but we'll focus today on a digital mapping tool, an innovative prototype to help to make better decisions to gain further renewable energy with the focus on biogas establishment of plants. And then we'll stop the recording and we'll come into open reflections, Q&A. Feel free to also write in the chat. Meanwhile, Maria, a colleague of mine, is keeping track of that, and we open up for that. And as a final point in those reflections, we also want to say thank you, but checking if there's someone out there that wants to be part of further projects and development. So keep those things for yourself as a notice as such. Bioze, an abbreviation. In this sense, biomass skills for net zero. We all feel the challenges of climate change, and our objective is to help the green transition and use the potentials with biogas productions in regions, in a regional setting as such. And that's been a convenient funding then with European Union, a small-scale project by Interreg North Sea. It were running for 18 months, and we have just ended actually. So we feel this is part of further dissemination, and you can reach out to us afterwards and follow up. You can go to the interregnorthsea.eu/Bioze. Our main target group, and today there is various actors included in this session, but our main target group has been public actors, for example, municipalities or regional authorities, to help them overcome various obstacles. So we've been 6 parties, I mentioned those earlier, from 4 countries and regions, and our 5 deliverables include local and regional workshops. Those are among the most fruitful and delightful experience of really taking on the challenging questions, seeing how can we have the transition accelerating. But we've also made a state-of-the-art report that is available both from country areas and overall summaries and conclusions. An FAQ, frequently asked questions. Everything from what is biogas, is it hazardous, frequently asked questions. And today we'll focus on the digital mapping tool prototype. And we have also done a roadmap, one of the deliverables relating to a roadmap for how to go about when establishing a biogas plant. I mentioned the countries and the organizations, so I feel that we are all eager to progress. And what is then, just as an introduction, our digital mapping tool? It's designed to give a group, various people from different perspectives, to give such a group a better possibility to understand and plan. And we're comparing, with the help of innovative technology, different perspectives in a geographical space. And the majority of this is actually through a physical collaboration. So we have met people in the room in order to make areas happen. And part of our results, that is to find locations with the best suitability. And in this case, for biogas plants, using a multi-criteria analysis of farms, road infrastructure, and overall gaining understanding, providing social learning, and thereby defining policy or changing policy. Also, results that can be utilized when working with energy planning, making a business case, and co-creation between various actors. But to some extent, it's always easier to find things in reality. So I just want to share, not to brag too much, but for those of you who knows Frans Timmermans, he was one of the commissioners in the European Commission. And at the slide there, you see him together when meeting Professor Johannes Flanke at the University of Twente and so forth. And we sometimes say he was a guinea pig. Before, on the upper slide of the picture, a number of us met in Germany with regional authorities and various actors, and on a touchboard, a digital touchboard, working with various screens and utilizing heat maps with different dimensions and taking those together and against each other, but overall in terms of finding better possibilities. And with that, I'm actually suggesting, and I hope, Johannes, you're still with us, right? Johannes?
Yes, I'm here, Magnus.
Yes. Wonderful. Why don't you take us further so that you stop sharing your screen directly into our tool, and may all good parts be with us. But I remind, this is a prototype and in a explorative environment where we go through various phases and iterations. But please go ahead, Johannes.
Okay, thank you very much, Magnus, for the nice introduction and overview of the program. Let me share my screen and allow me to say a quick welcome and hello to all participants also from my side. I'm Johannes Flanke, as mentioned already. I'm Associate Professor for Spatial Planning and Decision Support Systems at Twente University in the Netherlands, in Enschede. And I'm happy to present the tools, one of the tools that we developed in the context of the Bioze project that was just described by my colleague, Magnus Kuschel. Please confirm, do you see my screen now?
Yes.
Okay, great, wonderful. So allow me to share just very quickly 2 more slides to put a bit into the story that I'm telling into a context, and then I'd like to do a hands-on demo of the tool, which actually, as you saw in the slides just presented, is actually made for people meeting in a space and discussing together face-to-face, but I'm happy to present it today online. So first of all, the problem related to the bioenergy and the biomass problem as such that we try to address with this tool is to find location for large-scale digesters. I'm sure you all have a bit of knowledge on biomass and bioenergy, so you might be aware finding locations of large-scale digesters and setting them up is burdened with a couple of problems. Setting up was very capital intensive. It takes a quite long time, and the most problematic issue is to find proper locations for that, because there are different NIMBY issues always around the table among different stakeholders, and NIMBY well, is an acronym for not in my backyard. So, and I'm sure, but I'm happy to hear your feedback if you say your own, you share your own experience with that. There are different regulatory restrictions also in the different countries that we, of course, dealt with. And there are issues of land ownership, and you have multiple actors that all have a different idea about that. And that's why we developed the tool to bring different stakeholders, different actors together. What the goal of the tool, I'm just moving one more slide forward, and then I go to the tool itself. Our goal with this tool development was to answer the planning question that we phrased like, what's the ideal combination of location for large-scale digester plants to be able to process a specific amount of manure in the region based on a pre-selected suitable set of suitability criteria? So we first do suitability analysis, and then we run an optimization process to find out what is the optimal location of certain locations for enhanced bioenergy production. The learning objective, as you can see on the slides, we developed a tool to make people, make stakeholders, actors understand about the trade-offs and benefits of the placement of such large-scale digesters, understanding of the problem, of course, and make each stakeholders understand each other better and their preferences and their pain points, because that is actually what it needs to make people come together and implement things and get plans going. And now it's switching to the tool as such. And now what you see here is a website, an online tool that we developed. My colleagues, and Peter Nuria is also joining the session today, and Ben Yu, who did most of the programming work in the tool. You might be seeing the little URL on the top of the screen, but otherwise one of my colleagues maybe can also post it in the chat. It's an online open source tool that we developed, and feel free after the workshop today to try it out for yourself also. Yeah, try it out.
Yeah, do it afterwards. Do it after the demo right now.
Yeah, not do it now. Let me first do the demo now. Thanks, Magnus. But feel free to try it out and feel free to give us feedback and to get in touch with us if you have more questions about it. The way we designed the tool, and Magnus was showing that figure already. This is crucial for us here. In lots of discussion in the co-design process, together with all the partners in the Bioze team, we structured the tool along a two-stage process, where the first phase here, we run, or stakeholders, users run a suitability analysis to determine different potentially suitable locations for large-scale digesters within a certain given region. And the demo that I will be showing today, we use the region of Twente, a region of 14 rural and urban municipalities, for those who are not familiar with a region in the very east, close to the German border, very east of the Netherlands. But you can, as it's being open source developed, of course, transfer it rather easily with the data to any other kind of location within Europe. The first phase is a multi-criteria analysis that results in a list of potential candidate sites, we call it. And then in the second phase, we go into an optimization process where users can explore different pathways of optimal allocation of manure to digesters in relation to the different farm locations by optimizing, first of all, the amount of biogas produced, but also optimizing in the sense of limiting the transport cost and the transport greenhouse gas emissions occurring related to transferring the trucks from the farms to the digesters. I now click here. You see on the very left side the table of content. I click here now on phase one, the suitability analysis. In the phase one, we define 2 steps. The text, I suggest you have a look afterwards. We defined and selected together with the colleagues in the project 7 different suitability criteria that are the most common ones that play a role for finding locations, for suitable locations. And if you hover over this, you see for each map, the definition of the criteria is given. These are single suitability maps that define, and let me show one map here in large, just by clicking on it. It's a map made, this is our area, and the map shows the suitability of hexagon. We did it in hexagon tessellation. Suitability of hexagon location for, and this is the criteria, industrial area. The way you read this map says, the lighter the color, so these light yellow, orange colors, the better suitable is a certain location, a certain hexagon for putting up a digester. The darker the color gets, the more purple the color, the worse. Because, I mean, the way we set up this criteria is the closer to industrial area, the better, because you don't want to put digesters into new open agricultural land. You want to have it ideally on the industrial terrain, or at least close by if the industrial area is full. And likewise, we defined 7 other criteria, and I go quickly through them. Feel free to ask at the end other questions if you want to understand better. So this first one is farm locations. Here the definition of the suitability criterion is, of course, the closer the better. The closer the hexagon is to a farm location, the better, because that minimizes transport efforts. The closer to industrial areas, the better. We had that already discussed in detail. The third criterion is the closer. Oh, I have to put it the other way around. That's about nature and forest area. And the way we defined it, saying the more far away from nature and forest area, the better suitable is a hexagon in a certain location, because you don't want putting a digester, of course, into natural reservoirs and forest areas. Quickly going through the next 4 criteria. Road infrastructure, again, to reduce transport efforts and costs. The closer to the transport area, the better. Same color scheme that you, by the way, see here on the bottom right. The dark black and purple colors are least suitable. The light red, yellow ones are most suitable. So transport area, the closer to the main transport connection network, the better. Urban residential area, the criterion is again the other way around. The more far away from urban and residential area, the digester is better located because it produces smell, odor, has a lot of traffic that it produces from the trucks. You don't want to have it close to the industrial area, was our interpretation. The gas inlets, of course, in the end, the biogas that is being produced, so the bioenergy needs to fit into the gas grid. That's why we defined here 1 criteria, the closer to the gas grid, the better, because that again reduces cost for building pipelines. And last but not least, the last criteria, proximity to water bodies. And again here, the more far away from water bodies, the better. These are the 7 criteria that we selected based on internal discussions. What the tool now allows is that users, stakeholders together, standing around the table or meeting online as we do right now, can select their most preferred criteria. I suggest not to start with all 7 criteria. That has a bit of processing time. Performance is then an issue. I would say, for the sake of this demo, now we start with 2 criteria. So I would, the most typical that comes to my mind, let's say we want suitable locations close to farms to reduce transport efforts, and we wanted to have it close to industrial areas to make sure they are matching within the urban built-up area and urban built-up design. We have now chosen 2 criteria. Of course, you can always go back and forth, add more criteria, take criteria out and run it again. I click now on the button on the left, build suitability map. It takes a little while. You see here that little icon on the upper right that gives us an information how long the system running, and you get maybe now an idea already why we take only 2 criteria, not we do it with 5. If you have any particular questions about multi-criteria evaluation, how it works, we can discuss later. For the time being, I can say we excluded weighing. We decided not to build in a weighing. We try to keep it simple. That means all criteria that you select have the same weight. But of course, technically, a weighing where stakeholders can say the indicator farm proximity is for me more important than industrial area proximity. You can build that in, or we can build that in if you consider that relevant. That can be discussed. Now we have a result. Let's scroll down a little bit, and we see here a curve, a distribution of the. You see the system has now selected 16 different locations within the entire area, and this little graph here shows it scores 16 different locations that all score between 0.88 and 0.98, so scoring quite high, having a different overall suitability score. For those who are not familiar with suitability mapping, scores are ranging between 0, meaning a very low suitability, and 1, a very high suitability, the highest suitability. So the system gives above a certain threshold the most suitable areas. Let's assume we are fine with that. Of course, you could now study the map and go back and change criteria. We enter into a second phase now with this predefined result of 16 criteria. Well, that is working. Any questions already so far?
No, but 16 suggested places
Yeah.
for this multifunctional group to discuss. Which of these 16, will it be where I live? Will it be where it's already some planned? Will it be 16 good things are taking us further?
And we have a look at that. Thanks, Magnus. Indeed, this is, and I show you a map now, how it looks like. So we go into step 2, and you see here now a map, bit more easy to read map of the area of Twente. Let me make that map a bit bigger. You see in this map now with this numbered dots in different colors, these are the 16 locations that came out of the step out of the suitability analysis. Yeah, so these are 16 potential candidate sites that now we stakeholders would typically first discuss, study, interpret the map, look at different locations. You can go closer. So those are familiar. Well, this is Tübingen. That's a small city in the north of the region. Almelo is a bigger city, and you see here it's quite close to industrial areas, which are typically on the edge of different rather urbanized areas. This is Enschede, where our university is. In the center, of course, is all urbanized area. In the surrounding, there are some industrial areas, and close to that, the system found no candidate site that are being suitable, potentially, or candidate sites for putting up digesters. I'd like to now move into the next phase, which we call the optimization, because based on this map or inspection of this map with 16 candidate sites, stakeholders, again, around the table or online may suggest, okay, we don't want to have it allocation of we don't want to run the next step with all 16 locations. Let's first make a selection. Our preferred sites of these ones are, and they're just given by number here. Let me just pick a few ones. How do we perform if we choose locations 1, 4, and 6? Honestly, I haven't predefined that. I just now would like to run the first optimization with these 3 sites. Submit. And the next setting that the model you can do in the model is define my policy goal would be, say, 20%. You see this slider bar here on the left side. 20% of the entire manure that's occurring in all farms in Twente shall be processed. If you work with 3 sites and 20%, the optimization would say, okay, if you do it like that, then we, or the system in that sense, now suggests these 2 locations to be selected as candidates, as sites for digesters, and these little arms or deltas here that are pointing at different farm locations, which I should visualize. Sorry for that. Coming in a minute. Oh, now I have to do it again. Pardon, that was my mistake. Let's run it again. Now run it with 30%. Now we get a slightly different results. More farms are delivering the manure, or supposed to deliver the manure, to these 2 located sites. And you see, seems like we have a little bit of a bug. I'm not understanding why it always goes back to 0 here. Let me try it once again. Sorry for this little hiccup.
Johannes, we had a question here about the choice, if it's based only on minimized transport.
The minimized transport is included in this stage. So in stage 1, the transport is by selecting the criteria closer to the road. And here this optimization of farm location is indeed based on not the Euclidean distance between the farm and the hub, the digester hub, but based on along the transport route to the from the farm to the digester location. Yeah, and just hope that is clear. If not, I'm happy to come back to that point, just to show the final result, and then we're done with a rushing quick run through the tool. The tool gives here now the efficiency of the capacities. We see now 2 locations are selected. The first location, location number 4, runs at a efficiency of 70% or capacity of 70%. Location number 1, the digester only processes a little bit underneath 50%. So one could even say, okay, let's see how we can run the increase the efficiency of 2 locations by, it can even do 30%. So the way we design the tool is it selects limited number of locations for putting up a digester, but runs these by full capacity. One last demo, and then I'm happy to take any kind of questions. If you go, let's say, if you go for 40%, then both locations that before are running almost full capacity, and location number 6, the third one here in the south, close to Haagsbergen, is also suggested, but runs at a lower frequency. So it's sorry for that. In summary, the model allows rather quickly to simulate and run different options of what is my optimal location, optimized allocation of resources to different farm locations. And if you now want to do a run with other locations, you would go back here, take one location out, add another one to it, and run it again. So that's a back and forth in both in the amount of manure processed or also the allocation, the location chosen from the candidate side. So far, I would like to talk through the tool, but I'm happy now to take any kind of comments. And if my colleague wants to add something I've forgotten, or please do so. Thank you. Magnus, do you want to take over and moderating again?
Maybe it's good. Karin, feel free, anyone now. We're not that many, but it can be good. Raise your hand or do like Karin, who is at Linköping University, one of the universities in Sweden. And Karin, you have also worked a bit on also towards the Karin, would you please share a little bit if you had some both questions and comments. Do you feel comfortable with that? You wrote it very well, and then we can get into dialogue. And maybe now, Maria, we should end the recording and thank everyone so far. Now we go into more of a reflection mode. And we see more questions coming in. That's good. So please keep it coming. And Maria, you're ending the recording, and then we take